Hello. Hi. Today we're going to talk about polynomial. Two important property of polynomial. First is remainder theorem, and second is factor theorem. Right. We cut straight to the point. So remainder theorem, when p of x is divided by x minus a, the remainder is p a. So what this means? This means, okay, I write it. The remainder of let's say p of x divided by x minus a is actually, you can just plug in a into the function, right? Let me give you an example. Let's say p of x is, well, maybe 3x cubed minus 2x and plus 5, all right? And I want to find p2 when x equal to what is the value of the function. Okay, I don't have actually, so let's plug in first. Okay, plug in into the function. So I get 3 times 2 squared minus 2 times 2 plus 5. It will be 3 times 4 minus 4 plus 5. It will be a plus 5. That's 13. Okay. But actually, I don't have to plug in member. I can use this function divided by x minus 2. So I can use 3x squared minus 2x plus 5 divided by x minus 2 and found the remainder of the expression. So let's do this, use synthetic division. Let's review it, okay? First of all, we check if we can use the synthetic division. Yes, because only when your divisor is x plus something or x minus something, we can use this method. Yes, it's x minus 2, so we can use it. This is negative 2, so first step, you change sign. Negative 2 become positive 2, you put here. Second, you copy down the coefficient of dividend, okay? And in standard form, standard form means your orders, the power of your x is from greatest to least. Okay, so coefficient is 3, negative, and 5. All right, and then you put down 3 first. Okay, we start to multiply, edit, multiply, edit, multiply, edit. So 2 multiply 3, you got 6, and then you add it up. Negative 2 plus 6 is 4, right? And then 2 times 4, you put it here, it will be 8, right? And then 8 plus 5 is 13. Wow, it's 13. I got the same result here and here. Well, yes, so I can use two-way to find remainder or find the value of p when x equals some numbers, right? So in this example, the function is quite simple. So the it looks the same. It doesn't make much differences, right? However, is if my polynomial is more complicated. For example, my p of x maybe is like 7x to the power 8 minus 24 x power to the 5, and then plus 2x to the 4, and then plus 10, something like this. If I want to plug in x2 into the function, it will be a little bit complicated. If I use the synthetic division, it might save you some time. Okay, so yes, that's why remainder theorem sometimes can save us some time, right? Some effort. All right, this is an important property of polynomial. Okay, I will explain why later on. Just remember this first. And second is factor theorem. Okay, it states if the remainder is 0 when p of x is divided by x minus 1, then x minus a, so x minus a, sorry, is a factor of p of x. Okay, so which means, so remainder is 0, right? Remainder is 0. That means, so I give you an example. Maybe p of x is, let's say, 3x squared minus 5x plus a minus 2. Okay, so if I divide by x minus 2, all right, okay, I use p of x divided by x minus 2. Okay, let me use the syntactic division. Okay, so again, 2. So change side 2 here, and copy down the coefficients 3, -5, and -2. All right, and then start at 3, put on here. 2 times 3 give you 6, right? And -5 plus 6 is 1. Okay, 2 times 1 is 2. And then -2 plus 2 equals 0. Okay, the remainder is 0. What happens? That means x minus 2 is a vector of this polynomial. Of course, because, so we say p of x, that is, this is a dividend, right? And equal the divisor. Divisor is x plus 2 times the quotient. Quotient is not 3, 1. It should be 3x plus 1 times 3x plus 1. All right. So x minus a is a factor of p of x. Okay. Why this is so important? Why this is so important? Because for quadratic is not that important, because we can find a factor of quadratic, not that hard. But if I get a higher degree, for example, if I got just 3, maybe f of x is 3x cubed minus 2x squared plus 3, maybe 4x minus 5. Right. I want to find a factor. I want to find a factor of. I want to factorize the polynomial. So I have to find a factor, right? Because is the degree is 3, we cannot use the old method like quadratic. So 3x squared minus 5x minus 2. I can use this 2, 1, negative 3, 1. We can use this method to factorize. But for degree 3, we cannot use that. So how can we do? We will try like f1, f2, okay, or f negative 1, or f negative 2. Okay. If f1 is 0, that means x minus 1 is a factor of this polynomial, right? I just state that if the remainder is 0, then x minus a is a factor of this polynomial. So if I plug in 1 and the result is 0, then x minus 1 is a factor of that function. Okay, I just created for you. Let me try this. 2, 2, 5, 2, 5, 7. Yeah, okay, try this function. That's, yeah. Okay. So if I plug in 1 to this function, there will be 3 minus 2 plus 4 minus 5. That will be 7 minus 7 is 0. So x minus 1 should be a factor of this function. I'm 100% positive, sure. All right, let's do it. Let's try the synthetic division again, right? So x minus 1, I put 1 here, and then 3, copy down the coefficient 3, -2, 4, -5. First of all, I put 3 down here, and then multiply 3 times 3 is 3, and then add it. All right, it will be 1, right? And then 1 times 1 is 1, and 4 plus 1 is 5. Okay, so here, and then 1 times 5 is 5. So we'll put it here, and then negative 5 plus 5 is 0. Okay, so yes, it can when this function divide by x minus 1, it has no remainder. It has no remainder means this polynomial is a factor of this polynomial. Right? I would say 3x cubed minus 2x squared plus 4x minus 5 equal, this is your divisor, times the quotient. Quotient here is not 315. Actually, it will be 3x squared plus x plus 5. Okay, if you start from this number, this is a constant term, this is your x term. This will be your x squared term, this one, 3. So times 3x squared plus 1 plus 5. Plus x, sorry, plus 5. Okay, why it is so important? Because okay, we're gonna move to the concept extend to module 5. When we see an equation like this, 3x minus 2x squared plus 4x minus 5 equals 0. When I try to solve this equation, when I want to try to find x equals something, I cannot until I can factorize this polynomial. If I can break it down into x minus 1 times 3x squared plus x plus 5 equals 0, then I know x equal 1 is one of the solution, one of the 0, one of the roots of this equation. Because when x equal 1, I plug in here that this equals 0. So satisfy the equation. X equal 1 satisfy the equation. So that x equal 1 is one of the solution. And then I can solve. When this equals 0, I can use the quadratic formula, right? Negative b pass on negative b squared minus 4ac. Okay, I will introduce this formula later. Not introduce, I think already see that, just review. Okay, so that's why the whole module 4 we practice the operation of polynomial. The purpose of that is to solve a quadratic, not a quadratic, solve the equation higher than degree 2. Maybe degree 4, degree 5. If we know how to factorize the polynomial, then I can solve the higher degree polynomial, right? Okay, so that would be very important. If you understand this concept, you upgrade your math skill set, right? Upgrade, become like getting closer to master, right? Right. If you have any questions, just let me know. Okay. Have a good weekend. Bye bye.